In this tutorial, we're going to learn how we can use SPSS for data analytics. Before going further, I would like to briefly explain the requirement for this tutorial. This tutorial requires 0 stat knowledge. It also requires 0 SPSS experience. So you do not really need to have any prior knowledge to follow this tutorial. So I actually have a nickname for this tutorial called Zero to Hero. And you can download SPS to try out for a few days for free from IBM website. I will provide a link down below in this video. After this tutorial, you should be able to know how you can do some common stat analysis. You also can interpret and report those analyses. And also you have overall knowledge framework of data analytics. This is the overview of this whole tutorial. It has 2 sections. The first section is called mean comparison. It has 5 lectures. The second section is called linear regression. It has 2 lectures. Why I structure the whole tutorial into 2 sections is because there are some differences between these 2 sections. The first section, the mean comparison, you can see that both sections for the dependent variable are continuous variable, but there's differences between the independent variable. For the mean comparison, the independent variable can be only categorical variable, but for linear regression, the independent variable can be categorical as well as continuous variable. Okay, you might have a question, what are categorical and continuous variable? Don't worry, I will explain you in a bit. That's why I say this tutorial requires 0 knowledge about any statistics. Okay, so let me explain what are the categorical and continuous variable. Before doing that, I would like to explain 3 data types in SPSS. The first is called nominal. So nominal is that there are different categories within a set. For instance, thinking about NLL, there are different positions within NLL. So these positions can be considered as different category within a set. And also different gender, male versus female, within the variable called gender. Ordinal is very similar to nominal. The difference is that it has some order within these different categories. For instance, high income, upper middle income, and entry level income. As you can see that there's some hierarchy within these different categories. Similarly, for language ability, you can beginner, intermediate, and fluent. So as you can see that these different categories have some orders. Another one is called scale. Scale is basically numerical values. For instance, age, you have 2, 18, 80, 99, 102. Income also have different numbers. But to simplify it, both nominal and ordinal can be considered as categorical variable. And for the scale, we call it as continuous variable. That's tied back to earlier I mentioned categorical variables and continuous variables. In this tutorial, I will only use the names of categorical variables and continuous variable moving forward. So you'll find that, okay, it's kind of easy to understand this tutorial. Okay, now we know the basic idea about categorical variables and continuous variables. And we're going to have a basic idea about data analysis, a basic framework. So basic framework, I call it IV and DV framework. So IV is independent variable and DV is dependent variable. Depending on the different data types of IV and DV, you need to use different types of analysis. I'm going to explain that in a bit. As you can see that, actually we saw this slide earlier, yes. So we know that for the dependent variable, it always continues, at least in this context. Of course, it could be other types of data, but that's beyond the scope of this tutorial. So in this tutorial, we're going to focus on dependent variable is a continuous variable. For the mean comparison, the independent variable is categorical variable. For the linear regression, the independent variable can be categorical or continuous variable. So that's why I say earlier, depends on different data types of IV and DV, you need to use different types of analysis. So we're going to look at mean comparison first. That's the lectures from 1 to 5, and we're going to after that we're going to look at the linear regression. That's lectures from 6 to 7. So the first section is about mean comparison. All this mean comparison, the dependent variable always continuous variable. The difference is on the independent variable. So first test in the lecture 1 we call one sample test, t-test. So for one sample t-test, the independent variable only have one category. Another one is called pair sample t-test or independent sample t-test. For this, it also has one independent variable, but it has two categories. Another test is called One-Way ANOVA. Again, it only has one independent variable, but it has two or more categories. So you can have more than two. That's a big difference compared to the t-test. Another one is called Two-Way ANOVA, and it has two independent variables. So the differences between One-Way ANOVA and Two-Way ANOVA is that One-Way ANOVA has one independent variable, but Two-Way ANOVA has two independent variables. Okay, now we have an overall picture of different types of mean comparison analysis. Now we're going to look at how we can do the first one, namely the one sample t-test. So we're going to learn one sample t-test in lecture 1. One sample t-test is to compare the mean of a sample to a fixed value. For instance, we try to compare the average score student rating to see whether it's different from 45 or not. So we predetermine the number 45 and then we do a comparison. For this, we can write down the non-hypothesis, which is that the mean of the rating score is not different from 45. In contrast, we can say that the mean of rating score is different from 45. Based on this example, you should have a basic idea about how to write non and alternate hypotheses. As we move forward in this tutorial, you will see more and more examples how to write non and alternate hypotheses. So even without any prior knowledge about hypothesis writing, I'm sure that after this whole tutorial, you will have a decent understanding of this topic. So now we're going to move to SPSS to see how we can do the one sample t-test. So this is the dataset we're going to use. And this dataset is about students' academic performance. I will put a link down below and you can download this dataset to do some practice. And as mentioned, we're going to test whether the rating score is different from 45 or not. So this is the column we would like to focus. How can we do that in SPSS? You can click the Analyze and click the Compare Mean and click the one sample t-test, and then click the rating and move it to the test variable, and then type the 45, and that's it. Click the OK, and the result will show up in the output window. So there are 3 tables in the output. The first table is just summarize the data, so it tells you that there are 200 rows of data. The second is the focus of the one sample t-test. It tells you the t statistics, and also tell you the p-value. And this last table, we do not really need to pay attention too much. It's about the effect size, and that's not really the focus. And as a beginner, you do not really need to pay attention too much. So this table is our focus. And I'm going to move to the slide to show you how we can write a report about this analysis. On this slide, you see two tables that just showing the SPSS. I copied them here so to make our discussion easier. As you can see that the mean of reading is 52 and the p-value is smaller than 0.001. That means that we're going to reject the non-hypothesis. As a reminder, the non-hypothesis is what? Is that the mean or reading score is not different from 45. We reject this non-hypothesis, then we go to the alternate hypothesis, saying that the mean or reading score is different from 45. So the alternate hypothesis is our conclusion. We say that the reading score is significantly different from 45. So this is the one sample t-test. Now we're going to move to the paired sample t-test. That is our lecture 2. As a reminder that the differences between one sample t-test and paired sample t-test is that one sample t-test only have one category within the independent variable. In contrast, paired sample t-test and independent sample t-test, we got two categories. For paired sample t-test is used when the category 1 and category 2 are from the same group of people or object. What do you mean by saying that same group? Let's see some examples. So for instance, for the same group of students, you try to see that whether their exam 1 and exam 2, their score are the same or different. Another example could be like, you want to see that for the same group of students, you want to see that reading score and writing score, whether they are same or not. So both examples, you can use paired sample t-test to do the analysis. In this tutorial, we're going to test that whether students' reading score and writing score are the same or not. For this, we can write a null and alternate hypothesis. The null hypothesis is that writing score and reading score are not different. In contrast, we say that writing score and reading score are different. To test this hypothesis, we're going to use SPSS. So this is our SPSS. We're going to see that whether the reading score and writing score, whether they are equal. So these two columns are the focus of this analysis. To do the paired sample t-test, we can click the Analyze and click the Compare Mean. So again, it's Compare Mean, this option, and then we click the paired samples t-test. And so we are going to click the reading and the writing and into the analysis to the variable 1 and variable 2. Other than that, we do not really need to do anything else. We can just click OK. It provides 4 tables. The first table, it just provides the means. So mean for reading and for writing. The second table, we do not really need to pay attention too much. It basically provides a correlation number. And another one is the third table is the focus of the analysis. It provides the t-value and the p-value. Last one again is the effect size, so we're not going to pay attention too much. Now we're going to shift to the slide that I prepared, and I'm going to show you how we can report the results of paired sample t-test. On this slide, you can see 2 tables we just sort in the SPSS. And we can see that the first table provides the means for reading and writing. For the reading, the mean is 52.23, while writing, the mean is 52.78. We can see that these two means are very close. The p-value is 0.387, which is greater than 0.05. so we fail to reject the null hypothesis. Whether we can reject a null hypothesis is dependent on p-value. If the p-value is smaller than 0.05, we reject. If it's greater than 0.05, we fail to reject. So here is the case that we fail to reject the null hypothesis. As a reminder, the null hypothesis is what? The null hypothesis states that writing and reading score are not different. We fail to reject. So we conclude that writing and reading score are not significantly different. So that's our conclusion. This is the pair sample t-test. Now we're going to see another t-test, which is called independent sample t-test. Before going to details of independent sample t-test, I would like to remind you the differences between pair sample t-test and independent sample t-test. Pair sample t-test is that the data 1 and data 2 are from the same group of respondents. So for instance, earlier we test that the reading and writing are from the same group of students. In contrast, independent sample t-test is for the situation where the x1 and x2 are from two different groups of respondents. So independent sample t-test is also called two-sample t-test. The first example is that we try to see the reading scores between female student and male student. And so we are compare two groups of students, male versus female. Another example could be like product quality rating. So we try to see that the product quality rating between fat tray A and fat tray B. So here, products are from two different fat trays. So both examples, we can use independent sample t-test to do the analysis. In this tutorial, we are going to do an analysis to compare the writing score between male and female students. The null hypothesis is men and women do not differ in terms of their writing scores. The alternate hypothesis is that men and women do differ in their writing scores. Now we know the null and alternate hypothesis, we're going to move to SPSS to do the test. So remember that we are going to test that whether the writing score is different between male and female students. So the writing score, this column data is our focus, which is the dependent variable, and this is the gender variable. It's a variable called gender dummy. So we use dummy coding here. So what I mean by saying dummy coding is that so now we see the label is female. Female is 1 and male is 0. So this is mainly the meaning of dummy coding means it's 1 and 0. And this is the label. And you can click this button to shift the different labels. So this is the independent variable. This is the x and this is the y. To do the analysis, we can click the analyze and click the compare mean and click the independent sample t-test. And I mean, actually I just did some practice earlier, but we can clean that. We can reset everything and then we can do it again. Okay, so click the writing into the dependent variable test variable, and then click the gender dummy into the grouping variable, and it is asking us to define the variable, so we need to tell them what kind of coding we are using. We can say that okay, 0 to 1, and click continue, and just click OK. I think that's it. The first table just provide the means, the second table provide the t value and the p value, and the third table is about effect size. Again, we're not going to focus this table, so we're going to focus on the first two tables. On this slide, you can see two tables from SPSS. The first table provides two means. We can see that the mean of writing score for female students is 54.99. The mean for male students is 50.12. As you can see that these two numbers are kind of different. Next, we need to look at this. So this is called Levine test. It tests whether the variance are equal across these two conditions. That's not really the focus. of our tutorial, you just need to remember that if you see that the significant lab value smaller than 0.05, you need to use this one rather than the one on the first row. So you need to use the second row. So again, as long as you see that the p-value is smaller than 0.05 for the learning test, you need to use the second row of numbers. That's what you need to remember for the purpose of this tutorial. So we use the second row of data, and you can see that the t-value is minus 0.656. So, and the p-value is smaller than 0.001. So we reject the null hypothesis. As a reminder, we need to remember what the null hypothesis is. So null hypothesis is saying that men and women do not differ in terms of their writing score. So we reject that. That means that we conclude that for men and female students, they significantly differ in terms of writing score. So that is the independent sample t-test. Now we have a basic idea about how we can do t-test. We're going to move to see how we can do one-way ANOVA and two-way ANOVA using SPSS. As a reminder, the differences between one-way ANOVA and t-test is that for one-way ANOVA, it can have more than two categories within the independent variable. Remember that for pair sample t-test and independent sample t-test, both of them can only have two categories. So if you have more than two categories, you can only use one-way ANOVA. So one-way ANOVA is to see that whether the mean of two or more than two groups to see whether their means are different or not. For instance, you can say that, okay, you try to compare the products from 3 different factories and to see whether product quality are the same or not. Another example is that you try to see the sales from 3 different cities like New York City, San Francisco, and Seattle to see whether the sales from these 3 cities are the same or not. In this tutorial, we're going to use the same data set, namely the student's academic performance data set. And the dependent variable again is the writing score. But here, the independent variable is not gender, which we use in the t-test. But here, we're going to use a variable which has 3 categories: vocation, general, and academic. So we're going to see that whether students from these 3 different programs, whether their writing scores are the same or different. So for the null hypothesis, we're going to say that, okay, the mean are exactly the same. There's no differences. In contrast, we're going to say that alternative hypothesis is that at least one pair of them is not equal. So that's the null and alternative hypothesis for the one-way ANOVA. Now we're going to move to SPSS to see how we can do that. So this is the SPSS, and we're going to focus on the writing as our dependent variable. For the independent variable, we're going to focus on 3 different programs: vocation, general, and academic. How we can do that in SPSS? You can click Analyze, Compare Mean, One-Way ANOVA, and then click this is independent variable, 3 different programs, and then this is writing score. And then you just click the descriptive, click option descriptive, because we want to see the means. And click Continue, and click OK. So this is the one-way ANOVA. It has 2 tables. The first table is the means, and the second table is the p-value and the f value. I'm going to move to the slide to show you how we actually can report this result. As you can see that on this slide, I copied paste these 2 tables on the slide. And as you can see that the first table provides the 3 means. So the mean for vocation is 46, the mean for general 51, and the mean for academic is 56. So the first is 46, and then 51 and 56. And then the f value is 21. And the p-value is smaller than 0.01. That means that we reject the null hypothesis. Remember, the null hypothesis is saying that they are the same, but since that the p-value is smaller than 0.05, we reject the null hypothesis and conclude that we conclude that, okay, at least one pair then is not equal. So here, as you can see, that this is basically we are done with the one-way ANOVA, since that we already finished, we already decided to reject the null hypothesis. But for the one-way ANOVA, since that we have more than two categories, so we're not sure that which pair is not equal. That's where the post-hoc test comes in. How we can do that? The way we can do that is that we can click the analyze and click the compare mean again. We just go back to the same menu, we just dig that. But here now we click the, as you can see that SPSS, remember what we just did earlier. So on the top of that, you just need to click the post-hoc and click the Tukey. I mean, that could be, you can use other tests, but here we just use Tukey. And then, okay, you do not need to do anything else, just click OK. So as you can see that now beyond this, the two tables we saw earlier, it also provide a post-hoc table. And let's shift to the slide, and I will show you how we can report the result. So this is the table we just saw in the SPSS output. As you can see that all these p-values are smaller than 0.05. It means that all these different pairs are they are significant. So the comparisons are significant. That means that these three categories are significantly different from one another. So so you can see that, okay, vocation is significantly different from general, vocation is significantly different from academic, and also general is different from the academic as well. So all these three, regardless what kind of combination, which pair you chose, they are significantly different. So this is one-way ANOVA. Now we're going to move to the two-way ANOVA. Two-way ANOVA is our lecture 5. As we see that we move very fast. So just a reminder that the differences between two-way ANOVA and one-way ANOVA is that for the two-way ANOVA, it has two independent variables. So it's very different from all the prior tests. All the prior tests we have discussed, they all only have one independent variable, but here two-way ANOVA has two independent variables. Okay, so what we're going to do in the two-way ANOVA, basically it tests whether the effect of one independent variable on y, whether it's dependent on another independent variable. I know this is a big mouthful, but let me explain to you. So I will use an example to explain the two-way ANOVA to make our life easier. So suppose that the first independent variable x1 is a brand, so different brand like brand 1 versus brand 2. And the second independent variable is x2. We call it city, so city 1 versus city 2. And then the dependent variable is the sales. So we have two independent variables, s1, s2, and dependent variable is y sales. And so if we observe the differences, saying that the sale of brand 1 and brand 2 are different. So suppose that brand 1, the sales is higher than brand 2, so there's differences. For this, we call it there's an effect of x1 on y. So as long as there's differences, we call that effect. Beyond that, if brand 1 and brand 2, the sale differences in city 1 is much bigger than the city 2, we say that the effect of x1 on y is dependent on x2, which is the variable of city. So this is the basic idea about two-way ANOVA. We're going to use an example, exactly these three variables, to show you what I mean by saying that. So hopefully you will have a better idea. So the null hypothesis is that the effect of brand 1 and brand 2 on sale doesn't depend on the effect of city. Namely, there's no interaction effect. So for the interaction, I'm going to explain what interaction effect is in a bit, so don't worry about that. But again, the alternative hypothesis is that the effect of brand basically just like remove the not. So it depends on the effect. So that's the interaction effect. So this is a non and alternative hypothesis. Now we're going to go to SPSS to see how we can do the test. This is the data we open in the SPSS. this is a new data, so which is different from our student academic data. I'll also post this data down below, and then you can download this data set to do some practice. So you can see that on this data set, there's a city, that's the one of the variable, and the brain, that's another variable. So as you can see that city has two labels, city 1, city 2. Brain also has two labels, brain 1 and brain 2. And the dependent variable is sales number. So this data set is pretty simple. And so 2 independent variable and 1 dependent variable. And we're going to do two-way ANOVA using this data set. How we can do that? Click the Analyze and click the, now here we're not going to compare mean. We're going to the General Linear Model and click the Unique Variate. So, and then click the sales into the dependent variable and click the brand and the city into the fixed factors. And then click the option. I think we need to click the descriptive analysis because we're not show the mean. And click OK. And I think that's it. And click OK. So this is the output. There are 3 tables. The first table will tell you that, okay, for the each brain, like for brain 1, brain 2, how many observations you have, and the city 1 and city 2, how many observations you have. And another one is like for the, it also on this table it calculate the means, and on this table it calculate the interaction effect. So this is the interaction effect for the L value and the T value. Now we're going to move to the slide I have prepared. I'm going to show you how we can report and interpret the results. As you can see that this is a table we just solved. This table is the interaction effect. As you can see, we focus on the L value and the P value for the interaction effect. We can see that the P value is smaller than 0.05. It means that we reject the null hypothesis and saying that the interaction effect is significant. The question becomes that what it means by saying that it's significant. Then we need to go to the bin, see the bin. So this is the tables providing all the mean values. And we're going to focus on these 4 means. So remember it's 2 by 2, so we have 4 means, yes. And we're going to put these 4 means into a table. Then you have a better idea what these 4 means telling you. So this is the table. So basically it has 4 means and also did some simple calculation. So this is the first calculation. It shows that for the brain 1 and brain 2 within the city 1, and you compare differences, yes, the difference is like 48 minus 60.8 is 41.2. So this is the differences between brain 1 and brain 2 in city 1. Beyond that, you can also do the comparison, the calculation for city 2. Here the difference is 0.4. So as you can see that the differences, yes, for both city they have differences, but the differences is much greater for the city 1 compared to city 2. So that's the summarize of the findings. So the effect of brains on cells in the city 1 is different from city 2. For this, we say that the effect of brain on cell is dependent on the effect of city. Namely, there's an interaction effect. So now you have a basic idea about interaction effect. I mean, for this tutorial, it just really provides you some introduction. Now you have some basic idea. I have some other tutorial on my channel about interaction effect. You can go to watch those tutorials. But the purpose of this introduction or interaction effect, I think you have to have a basic idea. And we can also do some plot. We can plot a bar chart to show this interaction effect. I mean, hopefully visually, this visual information can give you a better idea how we can do the plotting for this interaction. As you can see on this screen, I just copied and pasted these 4 means on the Excel. And you can just select them and then click Insert and then click the bar chart and then click the first option. So as you can see that this is these 4 means represent these 4 bars, yes. And we can make this bar chart looks prettier. You can add a min as well, add a data, add a min, and add a data label. And then, I mean, you can also add add a line, solid line. I mean, click this solid line and click to black color, and this also solid line, black color. And you can also no field, no line, no border line. As you can see that now the chart looks a bit more professional. Yes. So the basic idea about that is that, as you can see, that this bar chart show you that it compares brain 1 and brain 2 for 61 and 62 separately, and for 61 the brain 1 is roughly 48 and the brain 2 the 6.8. So as you can see, the differences is much greater compared to the brain 1 and brain 2 in the 62. So this plot basically is help you to understand the nature of interaction, which is that the effect of brain on the cell differs across these two levels and on another variable, the 60. So hopefully this data visualization helps you to better understand the meaning of interaction. Now we have finished all the lectures within the section 1. Now we're going to move to section 2, which is about linear regression. And we have 2 lectures. One is a simple linear regression, one is multiple linear regression. Let's see the simple linear regression first. So what's the basic idea? What's the differences between mean comparison and linear regression? The only difference is on the independent variable. For the mean comparison, the independent variable is categorical variable. For the linear regression, the independent variable can be categorical or continuous or both. So let's first look at the simple linear regression. Simple linear regression is to estimate the relationship between one independent variable and one dependent variable. For instance, if we want to use the writing score as a way to predict the reading score, we can write a statement like this. So reading is the y and the writing is the x. And we're going to estimate the B1. So for the null hypothesis is that there's no relationship, so namely B1 equals 0. The alternate hypothesis is that the B1 is not 0. So this is the non and alternate hypothesis for the simple linear regression in this example. Now we're going to move to SPSS to see how we can do that. Now we come to SPSS. We're going to see whether the writing can be used as a way to predict the reading. In order to do that, we can click the analyze and click the regression and linear. And we click the write as dependent variable and the read as dependent variable and the write as independent variable. Other than that, you do not really need to do anything else. You can just click the OK. So this is the output. And it has 4 tables, and we're going through each one to see what they are. The first is a table to tell you that, okay, what variable is in the model. So we tell you that, okay, writing is the independent variable in the model. The second one is a model summary. So I'll be briefly explain to you what it means. So the R square. So R square is tell you that, okay, how much variance of y is explained by the writing. So here 0.356, it means that 35% of the variance in the reading is explained by the writing, this predictor. So that's the basic idea about second table. The third table, we're not going to go through that. The basic idea is that there's a connection between ANOVA and linear regression model. So that's a bit beyond the scope of this lecture. We're not going to go through that. The focus of this lecture is the last table, the regression coefficient table. And I have copy paste this table into the slide, and I prepared a slide. Let's go to the slide to see how we can report and interpret the result. This is the table, the last table in the SPSS output. As you can see that here, there's a regression coefficient for the B1. So B1 is 0.646, and the p-value is smaller than 0.05. Actually, it's smaller than 0.001, but our cutoff point is 0.05. So it means that we can reject the non-hypothesis. And therefore, we can say that, okay, writing score can be used as predictor for reading score. And we can actually write out this statement. So this is the intercept is 18, and 0.65 is for the B1. So what it means by having this statement, it can help us to understand the relation between reading and writing. So this statement tells us that for writing score to increase 1 unit, the reading score will increase 0.65 unit. That's the basic idea or the meaning of this statement. Okay, so this is for simple linear regression. Now we're going to move to the last lecture of this tutorial, which is multiple linear regression. That's our lecture 7 actually. So multiple linear regression is the relationship between multiple independent variable and one dependent variable. So this framework we have used a lot in this tutorial, yes. So x and y, independent variable and dependent variable. And for the simple linear regression, only have one x. But for the multiple linear regression, we have multiple x and one y. So x is called independent variable and y is dependent variable. So here, we're going to test the model. So remember earlier, in the simple linear regression, we only have the writing as one single predictor. Now we add a mass. We'll see whether the mass can also explain students' reading score. So here we're testing two regression coefficients. So there are two sets of non and alternate hypotheses. So the first set is about the B1 and the second set is about the B2. So we'll come to the SPSS. We click the Analyze, Regression, Linear Regression. And so SPSS, just remember what we did earlier. So actually we just need to add a mass into the independent variable, and we just click OK. So this is the output actually. It's basically the same 4 table. I mean, we have 4 tables as in the simple linear regression. And the first table again tell you what variable in the model. So you can see the differences. Earlier we only have writing, now have mass and writing. We have 2 independent variables. That's what this first table tells us. The second table tells us that how much variance in the y in the reading is explained by mass and writing in total. So we have 49.6% of the variance in y is explained by these 2 variables. So this is higher than the early only have simple one predictor. Yes, early only 35. Now we have 49. So as you can see that as you add more independent variable, it can explain more variance in the y. And the third table, again, we're not going to go through that. Last is the last table, and which we're going to focus on. So let's move to the slide, and we're going to see how we can, report the result based on this table. This is the table we just saw earlier. So as you can see that for both the writing and mass, the p-value is smaller than 0.01, and thus will reject a non-hypothesis. And based on the output from the regression coefficient, we can also write out the statement. So the intercept B1 and B2, we can write out. What it means for this statement, it tells us that for writing score to increase 1 unit, the reading score will increase 0.33. And for math score to increase 1 unit, the reading score will increase 0.52. So that's what these regression coefficients are telling you. So I think that's it. That's for this is the last lecture for the whole tutorial. So hopefully you learn something useful from this tutorial. You find this whole tutorial useful. Please like this video and also consider subscribing to my channel. And the more likes I receive, I'm more motivated to make more videos. Thank you for watching.